Hey, Algebra 2. Wanted to review what we did before break because this is going to show up on your next test. So the first thing that we did was composition of functions. Let's suppose that we have these three functions, f, g, and h. And the problem says find f of h of -9. How would you solve this? So we start at the inside and then we work our way out. We first are going to find h of -9. So h is my function. So up here it says that is x plus 4. So I would put that on the other side of the equal sign. Whatever you have right here in the parentheses is what you substitute in for x. So h of -9 equals -9 plus 4. So h of -9 equals -5. So it's as if you could cross this out, and that is now -5. So now we're going to take that, and we're going to do step 2. So this says find f of -5. So now f is your main function that we're using, which is x squared. So remember, whatever you get for this first part, that's what you're plugging in place of x in the second part. So f of -5 is -5 squared. -5 times -5 equals 25. And then we did, I let you try number 2 in class, and you can check the notes later and you should get 10. Let's say that we have functions and we want to find g of h of x. So whatever letter comes first, I think of that as my main function that I'm going to use. So on the other side of the equal sign, I would write down x plus 6. Get rid of h of x and plug that function in. So that's 3x squared. Remember, whatever you have here in the parentheses is what you substitute in place of x. So replace x with 3x squared and bring down your plus 6. That one was short and sweet. The next one's a little bit more involved. I'm going to work the other way, and I want you to find h of g of x now. So h is your main function. So I'm going to start by putting that on the right side of the equal sign. I'm going to replace g of x with x plus 6. Remember, whatever you have here is what you replace x with. So I have 3 times x plus 6 squared. When you square something, that's the same thing as multiplying it by itself. So I would rewrite this as x plus 6 times x plus 6. Now we're going to FOIL, multiply, distribute, whatever it is you like to call it. X times x is x squared. X times 6 is 6x. 6 times x is another 6x. And 6 times 6 is 36. I would combine like terms next. So I have 3 times x squared plus 12x plus 36. And then I would distribute the 3 as my final step. So I get 3x squared plus 36x plus 108. So if when you do composition of functions, if you get the same answer, you've probably done something wrong. That should be one red flag that you see. The next thing that we did before break is section 6.2, and it is inverse functions. Inverse functions is basically means you switch x and y. So we have these three ordered pairs, xy, 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 and when I find the inverse of it, I'm just switching them. So this first ordered pair becomes 3, 0. This second ordered pair becomes 2, 4. And this last ordered pair becomes -6, 5. So that is how you find the inverse when you're just giving ordered pairs. The next one, find the inverse of this function. So inverse means that you switch x and y. So then I have x equals 3y minus 1. And then from there, you want to solve for y. So I'm going to undo that subtraction by adding 1 to both sides. X plus 1 equals 3y. I'm going to undo this multiplication, and I'm going to divide both sides by 3. So I get x plus 1 divided by 3 equals y. And we should put this -1 exponent to signify that I found the inverse of it. So if it just says find the inverse, then that's great. You're all done. But in a lot of problems, it'll say, now graph it. So if it needs you to graph the inverse and you have two terms over one, remember that we can split this apart. And I have x over 3 plus 1 over 3. So if I just wanted to sketch this graph, so this is just the equation of a line in slope-intercept form. So the 1/3, whatever your plain old number is, there's your y-intercept. And then the number with the x is the slope. So there's an invisible 1 in front of x. So this slope is 1/3. So after I plot my y-intercept, my plan is to go up 1 and right 3. All right, so my y-intercept is 1/3. So we're just going to estimate something in between 0 and 1 on the y-axis. And then I'm going to do up 1 and right 3. And that's probably good enough today. Connect the dots, and there is my inverse line. And then if I wanted to graph my regular line, my original line was 3x minus 1. So I have a y-intercept here at -1. I would go up 3 and right 1. And that would be the graph of my original function. And then we have to find the inverse of something with a radical and find the inverse of something with an exponent. So if it starts off in function notation, first thing that you want to do is get rid of that and change it to a y. Next thing we're going to do is we're going to switch x and y. So x equals 2 radical y minus 5. You always want to isolate your radical before you try to get rid of it. So 2 radical, that's multiplication. I'm going to undo that, and I'm going to divide both sides by 2. So I have x divided by 2 equals radical y minus 5. Exponents undo radicals. So since I have two terms on the left, when I square the left side, I need to put parentheses around it because this exponent is going to need to be applied to both the numerator and the denominator. So that gives me x squared divided by 4 equals y minus 5. And then I would add 5 to both sides. You get x squared divided by 4 plus 5 equals y. And then let's switch this out for inverse function notation. Now let's find the inverse of 5x squared minus 1. So get rid of your g of x and replace that with a y. Switch your x and y, so x equals 5y squared plus 1. We want to solve for y, so my next move would be to subtract 1 from both sides. You need to get your variable completely isolated before you get rid of that exponent. My next move would be to divide both sides by 5. So x minus 1 divided by 5 equals y squared. Now I'm ready to take the square root of both sides because radicals and exponents undo each other. When you take the square root of something, you get two answers. You get the positive and the negative. So I have plus or minus radical x minus 1 divided by 5 equals y. And let's switch that out for inverse notation, g inverse of x. Back here on this step, when you take the square root of both sides, since there was a fraction here, you need to make sure that you make a big, tall radical sign because this entire fraction is all under the radical. It's not just the numerator. And that is a summary of how we did 6.1 and 6.2.